Okay, so now the rule that we're going to be looking at in this video is the quotient rule. And I have to say that the quotient rule is basically my least favorite rule at all. And so I'm going to show you how to use it as chain rule, product rule. But I will nevertheless teach you the quotient rule. And you can decide on your own whether or not you want to use it or whether or not you want to use other methods. There's the quotient rule. And the reason why I don't like it is because there's a lot more memorization than in the product rule. So if I look at my product rule, because there's a plus here, it doesn't really matter what order, because, okay, so we've got a whole bunch of things that are commutative. I should use the proper terminology. We're all talking about commutative and commutation. So what does commutative mean? Well, commutative means that u prime times v is the same as v times u prime. So a times b is the same as b times a. And so multiplication is commutative. At the same time, addition is commutative. So a plus b is the same as b plus a. So I could write these symbols I can flip those if I wish. I can flip those if I wish. I can take these two parts and flip them like that. Okay. Here, well, first off, subtraction is not commutative. A minus b is not the same as b minus a, and also division is not commutative. So a divided by b is not the same as b divided by a. So this rule here has two things in it that are non-commutative, which means that you have to remember precisely exactly what this formula is, otherwise you're going to get it wrong. Okay, so that said, let's just jump right in and use one. Why don't we do this one? Why don't we do e to the x, so put a polynomial up there. X squared minus 5x over e to the x squared. Why don't we do that? So we got a little chain rule in there as well. So then I'm going to say u is equal to x squared minus 5x. V is equal to e to the x squared. U prime is equal to 2x minus 5. V prime is equal to 2x e to the x squared. I skipped over the chain rule there because you guys can hopefully just be able to do these chain rule problems in your head now, simple ones. And so then I have to get the order right. It's this. Times that. Minus this. Times that. All over that squared. That squared. Okay, so now I can sort of, now I'm going to distribute. I'm going to take a e to the x squared out of everything. So I'm going to go 2x minus 5. I don't want any parentheses. 2x minus 5 minus 2x times x squared means minus 2x cubed. Minus 2x times minus 5x gives me plus 10x squared. And then that's going to be an e to the x squared over e to the x squared squared. That's going to cancel that. And I'm going to get y prime equals minus 2x cubed plus 10x squared plus 2x minus 5 all over e to the x squared. Okay, there's my answer. Now, how else can we do it? Well, what we can do is we can move that up and change the exponent into a negative. So I can go y equals x squared minus 5x e to the negative x squared. And now that I've written it as a product rule, now I don't really have to worry about order at all. And so I can say u equals x squared minus 5x, v equals e to the negative x squared. Then I can say u prime is equal to 2x minus 5, v prime is equal to minus 2x e to the negative x squared. And so then now I can just do it in whatever order I want to do. That times that, but I want to put the polynomial first. 2x minus 5 plus that times that distribute the parentheses, take out the e to the negative x squared, and I'm going to get 2x minus 5 minus 10 minus 2x cubed plus 10x. And you can see that I've got the same thing you can see that this and this are the same thing. And I kind of poached a little bit. That was a pretty easy one. But in general, I prefer to rewrite quotient rule type problems as product rule problems by making whatever exponents I've got negative. So let's do another one both ways, and I think I'm going to make this one its own video because it's important enough to make it its own video.